mu t plus sigma wt, where we can easily calculate that expectation of yt is same mu times t, and variance of yt is sigma square t. Now next example is Brownian bridge. What is Brownian bridge? Let Wt be a Wiener process and 0 strictly less than capital T less than infinity. Okay, then the new process defined by Zt, Wt minus small t over t, W capital T, 0 less equal to t less equal to capital T, is called the Brownian bridge, since z at time 0, z of capital T, and we have expectation of zt is also 0, you can check, and variance of zt is t times 1 minus t over t. Okay, so expectation of zt means wt minus t over capital T, W capital T. So this can be written as expectation of Wt minus t over t, expectation of Wt. Now this is 0 because we know that Wiener process has expectation 0, right? And look at the expression of zt. Now zt can be written as Wt over t over t Wt. This can be written as 1 minus t over t times W of small t minus t over capital T, W capital T minus W small t. Now we know from the definition of Wiener process that Wt and Wt minus Wt, these two are independent, right? Dependent random variable. Why? This is from process definition of Wiener process, right? So if you take variance for this, so variance of zt which is equal to expectation of zt square minus expectation of zt whole square, but this is 0, we have already seen. So now just do the square of this term and you can see, let me calculate for you, is that 1 minus t over t square expectation of w t square minus 2 times 1 minus t over t times capital T times expectation of wt times expectation wt minus wt, right, plus t over capital T square minus expectation of wt w capital T minus w small t whole square, right? So now this is only t, so 1 minus t over t whole square times t minus this is 0. You can check because these are the independent and all have expectation 0. So now t minus t whole square, and this is capital T minus t, right? So this is t minus t. From the, make sure you understand this line, why. So what this means, and now if you calculate this, you will get t times 1 minus t over t, answer. Now we will start some another sort of different process from the Wiener process, which is called integrated Wiener process. Integrated Wiener process. What is the definition? Let omega f p be a probability space the stochastic process defined by xt is integral from 0 to t ws ds t greater than equal to 0 is called the integrated Wiener processes. So recall that from the property of Wiener process, S goes to Ws at omega for is continuous for almost all omega in omega, right? Why? Check from the property of Wiener process from lecture 1. And the above, thus the above integral is computed in the Riemanns. Computed in the Riemann sense.